We lock it away and call it the test set. This data is kept totally separate, and we use it at the very end, like a final exam, to get an honest, unbiased grade on how well our model performs.
This gives us a super simple, repeatable 4-step workflow. Step 1, split the data, just like we talked about. Step 2, choose a model. We're going to use a really intuitive one called k-nearest neighbors. I'll explain it in just a second. Step 3, we train the model on our training data. And finally, step 4, we evaluate its performance on that test data we kept hidden.
So, how does this k-nearest neighbors thing work? Honestly, it's brilliantly simple. When we give it a new unknown flower, the algorithm just looks through all the flowers it saw during training and finds the one that is the most similar, based on its measurements, its nearest neighbor. And then it just predicts that the new flower is the exact same species as that neighbor. That's it. It basically learns by memorizing the training examples and makes predictions based on similarity.
All right, we've split the data, we've chosen our model, we've trained it. Now for the moment of truth. It's time to see how our little model did on its final exam, that test set it has never ever seen before.
So we're about to ask our model to predict the species for every flower in that hidden test set. Then we're going to compare its guesses to the true answers. How well do you think our simple little model is going to do?
97%. Wow, that is an absolutely fantastic result. Our model, just using that simple logic of finding the closest neighbor, totally passed its exam with flying colors.
But what does a number like 97% actually mean? Well, it means that for all the irises in that test set, data the model was completely blind to, it correctly identified the right species 97% of the time. This proves it didn't just memorize the training data, it actually learned the general patterns. It can generalize.
And just like that, we've done it. We've solved our botanist's dilemma. We went from a real-world question to a table of data, and then to a fully trained model that can act like a digital expert, identifying iris flowers with a really high degree of confidence.
So there you have it. That's the entire life cycle of a basic machine learning project, from a simple question all the way to a working model. We used a simple process and some data to teach a machine to be a pretty darn good botanist. It really makes you wonder, doesn't it? What other experts can we teach a machine to be? A radiologist? A financial analyst? Maybe even a music composer? The possibilities are just getting started.